So let's talk about the form A cos theta plus B sine theta. Example 44 is asking us to express A cos theta plus B sine theta in the form R cos open bracket theta minus alpha, where R is greater than 0 and alpha is less than 90 but greater than less than 90 degrees but greater than 0 degrees. So let's start. So we're being asked to express A cos theta, B sine theta, into the form R cos theta minus alpha. So the first thing I'm going to do is I'm going to expand cos theta minus alpha. So this becomes R cos theta cos alpha plus sine theta sine alpha. Distributive law, I'm going to have R cos theta cos alpha plus R sine theta sine alpha. Now, what I have on the left is equal to what I have on the right. So since they're equal, I can now compare coefficients. On the left, the cos theta coefficient is A. On the right, the cos theta coefficient is R cos alpha. So what this is saying is that R cos alpha is equal to A. They are both they are both the cos theta coefficient. The cos theta coefficient on the left is equal to the cos theta coefficient on the right. Now again, comparing coefficients, the coefficient of sine theta on the left is B. The coefficient of sine theta on the right is R sine alpha. So R sine alpha is equal to B. Now, from this, I can say that R sine alpha over R cos alpha is equal to B over A. The R's cancel. I can then say tan alpha is equal to B over A. And if tan alpha is equal to B over A, it means that alpha is equal to tan inverse B over A. So we find alpha. What we need now to find is R. Now, if I square R cos alpha, I'm going to get R squared cos squared alpha is equal to A squared. And if I square R sine alpha is equal to B, I'm going to get R squared sine squared alpha is equal to B squared. Now, if I add both, I'm going to get R squared sine squared alpha plus R squared cos squared alpha is equal to B squared plus A squared. If I factor out R squared on the left, I'm going to get R squared sine squared alpha plus cos squared alpha is equal to A squared plus B squared. Now, sine squared alpha plus cos squared alpha is equal to 1. So I'm going to get R squared times 1 is equal to A squared plus B squared. So r squared is equal to a squared plus b squared. And therefore, r would be equal to the square root of a squared plus b squared. So I was asked to express a cos theta plus b sine theta in the form r, which is the root of a squared plus b squared, the cosine of theta minus alpha, and alpha is tan inverse b over a. So essentially, that is what I was asked to do, to express a cos theta plus b sine theta in the form r cos theta minus alpha, and it is equal to the square root of a squared plus b squared cos theta minus tan inverse b over a. All right, so let's move on to example 45. Example 45 is asking us to express 2 cos theta plus sine theta, or 1 sine theta, in the form r cos theta minus alpha. So r we know is greater than 0, r is positive, and alpha is between 0 and 90 degrees. If I expand on the right, I'm going to get r cos theta cos alpha plus sine theta sine alpha, distributive law, plus r sine theta, r sine theta sine alpha. Now equating coefficients, I'm going to get r cos alpha is equal to 2, and r sine alpha is equal to 1. If I divide r sine alpha by r cos alpha, I'm going to get tan alpha, because the r's are going to cancel, is equal to 1 over 2, and alpha would be equal to tan inverse a half. All right, so just getting my calculator quickly. So alpha is tan inverse a half, and this says alpha is 26.6 degrees. So now I know what alpha is. Let's find out what is r. We know that r cos, we know that r squared cos squared alpha is plus r squared sine squared alpha would be equal to 2 squared plus 1 squared. R squared is common. Is equal to 4 plus 1, which is 5. Cos square alpha plus sine square alpha is 1. So we can just say r square is equal to 5. The opposite of square is square root. So r is root 5. And so if r is root 5, it means that 2 cos theta plus sine theta is equal to r, which is root 5, the cosine of theta minus alpha, which is 26.6 degrees. All right, so next we're looking at example 46. Example 46 is asking us to express 2 sine x plus 3 cos x in the form r sine x plus alpha. Again, r is greater than 0, so r is positive, and alpha is between 0 and 90 degrees, so alpha is acute. Expanding the right, we get sine x cos alpha plus cos x sine alpha. Distributive law. Equating coefficients. We have r cos alpha, which is the sine x coefficient on the right, is equal to 2, which is the sine x coefficient on the left. And we have r sine alpha, which is the cos x coefficient on the right, is equal to 3, which is the cos x coefficient on the left. Dividing r sine alpha by r cos alpha, we're going to get is equal to 3 over 2. So tan alpha is 3 over 2, and alpha is tan inverse 3 over 2. So alpha is equal to so alpha is 56.3 degrees. So now let's move on to find r. We know that r squared cos squared alpha is 2 squared, which is 4, and r squared sine square alpha is 3 squared, which is 9. We know that r squared sine squared alpha plus cos squared alpha is equal to 9 plus 4. Sine squared alpha plus cos squared alpha is equal to 1. So now I have r squared times 1, which is just r squared, is equal to 13. And r would be the root of 13. So now that I have r and alpha, I can say that 2 sine x plus 3 cos x is equal to the root of 13 sine x plus alpha, which is 56.3 degrees.